Hi, Michelle Glass here. Welcome back to another episode in Chapter 26, Lecture 26. And our topic for this video is how the urinary system is going to be involved in the regulation of blood volume and blood pressure. Obviously, the kidney is involved in the production of urine, and we can make either a dilute or a concentrated urine depending on the fluid balance in the body. And we will see that our sodium is also going to be involved in the regulation of our body fluids, and what we can think of here is pretty much wherever the sodium goes, the water will follow. If you have an elevated blood pressure, high blood volume, then you're going to see the release of natriuretic peptides from the heart, helping to bring that blood volume and blood pressure down. And we'll talk about that in more detail here as we go through. The reverse of that is a low blood pressure, which is going to initiate the RAS system. This stands for renin, angiotensin, aldosterone system. So this is something that we've talked about already. Both of these as part of our cardiovascular system. We're going to just repeat that information and add just a few more details as we see how these hormones directly affect the kidney. Okay, so let's start with our RAS. So in this case, we're going to see this renin, angiotensin, aldosterone system initiated when your glomerular hydrostatic pressure is low. If your glomerular hydrostatic pressure is low, then your glomerular filtration rate will also be low. And this could also be low because of systemic blood pressure. So if your systemic blood pressure is low, then clearly your glomerular hydrostatic pressure will be low. So this is the signature feature here. RAS can also be initiated through sympathetic stimulation, and you have a group of cells in the distal convoluted tubule called the macula densa. These cells are monitoring, I see a typo there, these cells are monitoring the osmotic concentration of the tubular fluid. If the osmolarity is low, that means that the fluid is too dilute, then we're going to initiate the RAS system there as well. Okay, so what's going to happen? When your glomerular hydrostatic pressure is low, the juxtaglomerular complex will release renin. We already know that renin is going to lead to the conversion of angiotensin 1, or activation of angiotensin 1, which will then convert to angiotensin 2 with the help of the angiotensin converting enzyme, or the ACE or ACE. Angiotensin 2 does several things. One of its jobs is to talk to the central nervous system. It's going to increase your thirst. It's going to trigger the release of the ADH, antidiuretic hormone, from your neurohypophysis. This will trigger facultative water reabsorption in both the DCT and the collecting duct. In addition, we're going to get the release of epinephrine and norepinephrine, which is going to cause vasoconstriction, increase your heart rate, increase your venous return, so really increasing your blood pressure. We also see that angiotensin 2 will trigger the release of aldosterone from the adrenal cortex. This is going to turn on that sodium, potassium, and the sodium hydrogen ion exchange pumps at the distal convoluted tubule. This will cause an increase in sodium reabsorption, which, remember, then is going to help pull more water back into the bloodstream. Also, pay attention that aldosterone, because we're exchanging sodium for both potassium and hydrogen, can lead to both potassium and pH imbalances. So there's a risk there. And then another job of angiotensin 2 is to constrict the efferent arterioles. That's going to be those blood vessels that are leaving the glomerulus. So that's going to increase the pressure inside the glomerulus. So all of these activities together are going to increase your glomerular hydrostatic pressure, you're increasing your systemic blood pressure, and also your glomerular filtration rate. Okay, so let's take a look at the reverse. When your blood volume is high, then your heart stretch receptors are stimulated, triggering the release of the natriuretic peptide. Natriuretic peptide is going to dilate your afferent arterioles, constricting your efferent arterioles. So you're pushing more blood into the glomerulus. You're making that exit smaller. You're building up the glomerular hydrostatic pressure. So you're going to increase your GFR. That's helping to really pull off your water, electrolytes, nutrients, and so forth into that filtrate, so that you're getting a good filtration that's happening at the kidney. Also, we see you're blocking the release of both the ADH and the aldosterone, so that's going to prevent your facultative water reabsorption and that selective sodium reabsorption. So instead of reabsorbing that water, it is going to make its way out of the body as part of the urine. And you'll see a reduction of thirst. So all of these together is going to reduce your blood volume and your blood pressure. That's it for now.